Good now. Okay, now I've started recording. So let me share that again. So last week we saw the flow charts, and the first thing that usually comes to mind is we discussed at length on the things you need to consider when you are doing if you decide to do a quantitative study. Among the things we mentioned, if you have to do a quantitative, that is a positivist research, you must have theory. The theory must guide you. The theory is the lens through which you study the phenomenon you want to study. And when you are doing a positivist study, it is presumed that you are going to collect numerical data. You're going to collect numerical data, and this data will be, gathered from the appropriate sampled population, which could be very generalized, can be generalized, and then this data must be analyzed. And usually when you are doing positivist study, has this philosophical, belief that reality is objective. So the context is noise. You are not interested in studying context. You are interested in studying generalities. And it is usually under some kind of controlled environment where you can control things. If it is a situation that is beyond, completely out of control, where everything might happen at once, where you have no control of the phenomenon or even the situation, usually flexible learning is very recommended. And if you are doing a positive study, usually your design is fixed, which means at the beginning you've already made a lot of assumptions before you. Like when you look at all the statistical method that has to do with positive study, the ANOVA, the MANOVA, the MANCOVA, multiple regression, you have to make, assumptions before you begin. So your design has to be fixed. You already know where you are going and what kind of data you are looking at. In flexible learning, in flexible design, which is the qualitative, you don't have this kind of control. For instance, we're doing a case study. If you're doing a case study, anything can change at any time. And you don't have control over the organization where you are studying. So that's why your design is flexible. You also need theory, but theory can also emerge. You can also begin without a theory. That's when you are doing grounded theory. You may actually begin without a theory, but the theory will emerge. But in quantitative, you must have theory from the word go. Did you get it? Are you all there? Can you hear me?
Yes, I can hear you very fine,
Yeah, please
Clement.
interrupt me at any point in time. That's the essence. We have to discuss, but we are here to discuss, but we cannot be talking all at the same time. So that's why I'm kind of facilitating what we are doing, So I hope the clarification I made at the beginning is very, very clear about when to choose if you are doing a positivist study. So when you are doing a positivist quantitative research method. So that's very clear. So if you have decided it's going to be or maybe looking at the question, and then you are able to figure out that the best approach to answer this kind of question, because you are not very sure, things are like emerging, and you need to understand in depth where the context actually informs, what you are doing. And understanding the context is part of understanding the problem. That is when you think about flexible, qualitative research. You want to understand things in depth. You want to understand the emotion of the people, their satisfaction, their feelings, because it is informed by the interpretivist philosophy, which presume that reality is socially constructed, through people's feeling, their meaning they attach to the world. And in this case, the researcher, you become the instrument. You become the instrument. Unlike in positivist quantitative study, where you need the reliability and validity of the instruments you are using measuring, the phenomenon. In qualitative study, you are interpreting. That is the idea of double hermeneutics. You are trying to understand the situation as much as the people also trying to understand you. So there is need for reflexivity on the part of the researcher. You can bias, you can be a possible point of bias in your research because you are the instrument. And the only way to prove the reliability, because the word reliability and validity, most philosophers, on the positivist orientation rejects the idea of reliability and the validity when it comes to qualitative research. In fact, there is a long philosophical debate on whether we can actually say that qualitative studies they are really reliable. But there is reliability. There is reliability. Qualitative studies it's an approach. It is a methodology of in social sciences. So we can have reliability, but our reliability usually comes among many other factors. Audit trail. Audit trail is trying to show every bit of what you did, the transparency to keeping an audit of what you are doing. That is how you ensure reliability. We have also the member check and the other factors that need to be considered. But among the most important part of your consideration, if you want to show reliability and validity in a qualitative studies, look at audit trail. So show whatever you are doing, how you did it, the papers you searched, how you searched it, when you searched it, and every other thing you did, So now we have decided to do a positivist quantitative study. We looked at the flow chart last time, and we saw that the first consideration is to think about the kind of data you have. All right.
Quick question, please.
Oh, yeah.
Yeah, I usually hear about positivist, like you're talking about quantitative approach. Now there is also positivist and qualitative approach, right? Can you try to elaborate a little bit about the difference between both?
Between positivist
and the qualitative aspect, because even in qualitative research they talked about interpretivist, criticalist, and also positivist too approach.
Yeah,
right?
we shall come to that. Yeah.
Oh, okay.
I understand it very clearly. Yeah, we don't want to, because we spend in the past weeks we spent a lot of time discussing about this, and we don't want to
okay,
go.
good.
That's why I said But if you meet me privately, I'm gonna tell you everything you need to know about it.
I appreciate it.
You can also listen to our Zoom conversations, stored on the cloud, on Google. But I will tell you the difference. The difference is in regard to the way reality is understood, because it is a philosophical approach to understanding reality. One assumes that reality is subjective, positivist. The other assumes that reality is socially constructed, that is interpretivist. And interpretivist usually goes with flexible design, and the positivist study goes with quantitative research design. So why the positivists believe that reality is subjective and the context is noise, we are interested in generalities, understanding factors responsible for whatever. The interpretivist is interested in understanding the feelings, the emotions, the ideologies of people, how they understand the world. And to do that, you need like a open-ended questions. We call it semi-structured interviews, to understand, to hear from people actually how they feel. But here in quantitative, you're not interested in what they are saying, understand? You're trying to explore factors that could be responsible. And usually you use survey questions, which are closed-ended questions, So there are many other things that need to be considered. We can discuss about that later. So now, from the flowcharts, we have to consider, first of all, the first thing that comes to mind while choosing a quantitative research methodology you are going to use for your study is to think about the kind of data you have. And then the second consideration is to think about, am I interested in exploring relationships or understanding the differences, between different groups? If you are interested in the understanding between the means of different groups, then if you have only two groups, you go for t-text. More than 2 groups, you go for ANOVA, and then the ANCOVA, the MANOVA, and the rest. If you are interested in the relationship between different variables, then the next question that comes to mind is, do I have a true independent variable? If you have a true independent variable, then you go for regression. And then also, we added last time, the PLSM also should be part of that aspect. And then if you don't have a true independent variable, you go for correlation. We also saw how you can be able to choose the most appropriate method. Now, today, I want us to think about this, what I'm sharing now. This is a rubric. This rubric will guide you in critiquing papers that you may come across, during the course. And this rubric was given by John Hilton for midterm exams, but it is very, very important that you have to understand this. And these are things you have to look out for when you are designing a positivist, quantitative study. First of all, think about the research question and hypothesis. The research questions and hypotheses are clearly articulated and textable. The research question in a positivist study, in a quantitative study, is different from that of a flexible design. Why flexible designs? For instance, case study might ask how and why questions. Positivist studies usually ask maybe what questions, what factors are responsible. So the flexible design might ask why are employees acting in a certain way. You want to understand why they are behaving in a certain way, or why a certain implementation in an industry is working the way it works. So there is always a why and how question, especially in flexible learning, in flexible research. So I always mention flexible learning because that's where I'm researching. So each time I mention flexible, the next thing that comes to my mouth is learning. So this research question clearly differs. We mentioned that the other time. So in a qual exams, you'll be given maybe the same, you'll be asked to design a quantitative and a qualitative. So they may be using the same research question. So you can tweak a research question to be quantitative, and I can also tweak it to be qualitative. Or you may be asked to come up on your own based on the papers we are given beforehand. To come up with there's always this kind of comparison. It usually comes up. Please, guys, can you just turn on your videos? I don't know why guys are sleeping. I don't want to be the only one talking and talking and talking. So the research questions has to be, and the hypothesis has to be clearly articulated, and the textable. What does it mean to be textable here? That points to, the kind of constructs. You already have the variables that you want to test. And like I mentioned the other time, if you are doing a quantitative study, if you are answering your questions in the qual exam, you must mention define your variables. Define your variables. Which among your variables is the dependent variable? Which among them, are or is the independent variable? Because that makes a whole lot of meaning, so that we, the examiner, will understand, which variable is actually predicting the other. So it's very important. So these variables has to be testable, and the testable in the sense that you have to conceptualize a construct and operationalize them such that they can be defined, they can be measured. The construct has to be measurable. So that's what it means that your hypothesis must be clearly articulated. So when you say, for instance, you say you say that performance expectancy will have a direct significant effect on behavioral intention. It is testable. Why is it testable? Because performance expectancy, has been operationalized. It has been conceptualized to mean, doing things with a system free from effort. I mean, that encourages you to do your job well, helps you improve your job. That's performance, expectancy. And then it has been operationalized using 4 scales, for measuring them. So it is not just choosing, mentioning variables arbitrarily. Those variables or constructs in your model, must be testable. And that's why you need a hypothesis. I mean, you need a theory, because these hypotheses are based on the theory. They are based on the theory, So if you're using like the U-Tout model, the hypothesis in your model is the 4 or 5 independent variables at the left side. So each of these independent variable is a hypothesis. You are hypothesizing their relationship with the behavioral intention and the usage. So does anyone have any question?
Yes, sir. Kamil, I would ask you, if you don't mind, can we use like actual research? So we're going step by step with this Rubric, and we just evaluate how the study is good or bad, and applying these 4 or 5. How many columns in here? How many rows?
This criteria.
Yeah.
Yeah, well, we are going to do that because this workshop, we are doing it in phases. We don't want to go to questions now. I understand what you mean. That's always what, former students, that's always what they do. I even have my own question answers, to the past qualifying exam. I have my own answers, which I will share sometime with you, but I didn't share it in the folder because AFAF asked me not to, So we shall come to the phase when we start looking at papers. It's going to be another phase. When we are done with all this, we are going to spend the last months, even if the semester ends, maybe I'm in Nigeria and we are still meeting, because this workshop will end in the month of May. So the whole June, July, I might be coming up on Zoom, so that at that time we spend the last few months dealing with past questions. So for now, bro, let's try to understand the fundamentals. These fundamentals will equip us to look at the questions. Believe you me.
Did you pass the exam before? Did you already get the exam?
The what?
Did you take the exam already?
Yes.
Okay, so you are very good. Instructor for this. You are a very good one.
Yes, so, I took the exams. I passed the exams, and I tutored the next set of students, that also took this exam. So I have gone through the whole research questions from 2008 or from 2018 to 2020.
I will never delete your number. I will never delete your number, Clement.
Yeah. So I have gone through. So I have had the privilege.
I will have you in my favorite list.
Yes. So more than any other person, I've gone through. More than any other person, I have gone through the CGU curriculum like twice. So whatever I'm telling you now, I have a reason why I'm telling you. Forget about the questions. It is going to be fun when we get to the papers. When we get to the papers, we're going to apply all this. Because I will always remind you. Look at where we need to apply. Look at what we need to apply. So don't worry about that. If we go into analyzing the papers, we may not be able to cover all this ground. Let us get the materials we need. Let's put the bullet on the gun so that when the time comes, then we begin to shoot. Now we don't have bullets yet, so we are trying to our gun. So yeah, good. Yeah, so it says here the hypothesis has to be well articulated. That's what I'm saying. You need a theory, and from what I explained is the hypothesis usually based on the theory. So if you are critiquing a paper tomorrow, you're going to ask yourself whether their hypothesis is based on the theory. It's one of the important things you need to consider. Because you have to theory, if you are using the U-Tout, for instance, your hypothesis using the U-Tout 1 or U-Tout 2 is to hypothesize that performance expectancy, effort expectancy, social influence, facilitating condition will have a direct, significant effect on behavioral intention. That is the hypothesis. If you added a new construct and operationalize the construct, so also that construct will be your hypothesis that this new construct you added to the model will also have a positive relationship with the behavioral intention. So that is the hypothesis you usually do. In most quantitative research studies, they may not make explicit the research question. So the hypothesis is usually drawn from the theory. Without a theory, of course, you cannot, because you are hypothesizing in the context of a theory. That's why it is a hypothetical, deductive method. And it has to be well articulated. Usually, they are very short and straightforward. Hypotheses are very, very clear and straightforward. performance expectancy will have a direct effect on significant on the behavioral. It's very unlike flexible qualitative research questions that can be very lengthy. Positivism is direct, very clear, testable, because the construct has been operationalized and the scale is already there. Maybe, of course, I don't need to mention about scale. We have already spent a lot of time talking about instrument validation. Yeah. So the population clearly identify and discuss how the sample will be selected. Usually, there's a lot of sampling techniques out there. There's a lot of sampling techniques. We have the randomized sampling, which is like the best, random sampling, which gives every member of that population an opportunity of being chosen. It is not based on convenience sampling. Convenience is because the population is not truly reachable, so you decided to use people around you, what is around you based on convenience. It could also be, we have also theoretical sampling, but we usually hear about theoretical sampling in qualitative research. Theoretical sampling is when the theory guides you on what next to do. So you are not the one choosing it. So based on the data you have collected and analyzed, the data tells you, look at what you need to collect more. That is, kind of theoretical sampling. So based on the data collected, the data gives you insight on where next to collect data. We have also snowball sampling. You bring one person and then they will help you to bring others. Kind of snowball sampling. So all these are kind of sampling techniques, many of them. Some of them, like the randomized sampling is a kind of probabilistic. We have probabilistic and non-probabilistic type of sampling. So we have it's based on the probability that every member of the chosen population has the chance of being chosen randomly. So you have to define how you actually the target population. The target population must be coherent with the kind of the question that you have a research question, the hypothesis. In this case, what it means here is that the sampling population is maybe you are interested in understanding what's the use of a system within a certain organization. So you have to identify the organization that can actually provide the information you need to answer the research questions, to test the hypothesis. So you must mention that if it is voters, then you tell us how you're going to get the voters. If it is students, then you have to sample which school or schools. And then also number is also very important. Significant sample is very, very important. You have to think about the population. Sometimes you have to decide on a very significant sample. Maybe you have 350 members of the population, but the sample must be based on the population you are sampling. Maybe say 1,000 teachers. So there's no way you can sample 1,000 teachers. So you have to choose a representative. Maybe the center of interviewing the whole teachers in the US, maybe decide to use the California database of teachers to, sample your survey, use them as sampling. Or I might decide to take a certain grade of teachers. So it must be clearly defined. The sample must be defined, and it has to be representative, because that's the way you can avoid the type 2 error. Which is if there is an effect, you will be able to detect if there is an effect. That is the better. The more power you have, the better you avoid the error, the type 2 error. So you need to have a representative sample so that your research can also be generalizable within that particular population. So you have to make it very representative. Sometimes we have a lot of softwares that helps to decide, which sample is good. So, but in a quad exam, usually what you say, okay, based on, I have to choose a representative sample. Remember what I told you in the qual exam, what they need you to prove that you know what you are going to do. So you have to mention the sample, that you are going to use a representative sample, and look at how you are going to collect the data from using maybe internet-based surveys, where you send out or email, whatever way you're going to share the sample to get the data. Provide accurate and thorough description of how the data will be collected, That is
Ibrahim has a question.
Okay.
Oh, yes.
Hello,
Hey.
Brian.
Yes, sir.
Yeah.
Clement, what about the sample size? Are there any rules we have to apply and follow for the sample size?
Yeah, sample size can usually be decided. We have a lot of tools. We have a lot of tools there to help you calculate the sample sizes. If you are doing an actual research, but within the context of a qualifying exam, what you need to mention, just mention that you are going to choose a representative sample. Sometimes it may be difficult to determine
the reason why I'm telling you that, because I have my friends, he just failed on the exam because one of the mistakes that he made, he didn't mention the actual size of the sample. And when he get back to Terry, he told him, how come you didn't just mention the sample size? He told him, I already have that 200 I mean case. He told him, if you mention that, you're good and you're best, but you didn't mention that.
Yeah, assuming from the, maybe say the database of California teacher, in California we have like 200, we have 200,000 teachers in California. Then you use all this sample calculator online. Use sample calculator. I don't need to go into that. That may take us time, you know. So you use the sample size calculator, plug in the population, and it will give you a representative sample. Maybe sometimes around 350 or more or less. We have sample calculators online. If you Google it, you can find one. Maybe say a sample size calculator. You don't need to do all these things in qual, because you don't have that time. Look at sample size calculator, survey system. If you are doing an actual research, you just work on this. Okay, look at the confidence. First of all, you choose the confidence interval, which is very, very important. So then choose a population. Let's say our confidence interval is confidence level is 0.05. Margin of error. The population is, let's say there are 200,000 teachers. We have 200 teachers. Calculate 0.05, and then confidence. I don't know if this one is really a good one. 190,000 calculator. Let me use Survey Monkey. Survey Monkey should be good. Survey Monkey. Sample size calculator. Maybe I will have to come back to this. I don't really want it, because I want us to speed up.
Yeah, it was the second link below.
It was the second picture there.
You click on the marketing stuff, the advertisement.
Market advertisement.
Go back to Google.
So if you go back and then go to the second link, it's gonna take you straight to that.
Okay, I have to go back. Okay, go back from here.
And then there's another link below.
Survey
Below.
Monkey sample.
Yeah.
Survey Monkey sample size, right? That should be this.
Yeah.
The link you're talking about.
Maybe that will work, and also you can scroll down. Yeah.
Survey Monkey sample size services platform. I don't know if they have it here.
Oh no.
No, I have to. This software should be created survey. I don't think this is where we should go. Maybe any of you can browse to see if you have you can find a good sample size calculator. We have the G power calculator, also the G power calculator for sample size. We have the G power calculator, sample size calculator. Oh my God. So look at Survey Monkey sample size calculator. Survey Monkey. Get started. This marketization. Sample size calculator. Okay, the sample size. Okay, you look at it here. The population size. Let's say we have 200,000. Confidence level, margin of error. So where do I click? 95. Usually in social science we go for 95 confidence level, and then margin of error. Margin of error is the 5. Sample size is 384.
Oh yeah.
So if your friend you are talking about, had he been, he was able. I mean, sometimes you're not aware, like in qualifying exam, it's all about proving that you have the knowledge. Assuming you are confronted with a question and you don't actually know the database, you don't have an idea of what the population is. In a qualifying exam, all you need to demonstrate that you know what you are doing. So in that case, you will say, assuming we have a 200,000 population size, assuming you have been able to, ascertain maybe from database or from wherever search, maybe, or data analysis, maybe your data mining, whichever technique you used to discover the actual population size. And imagine your confidence in level is 95 and the margin of error is 5%. Then using this, I will presume that a sample of 385 or 400 might be very representative. Just say it this way. It shows you know what you are doing, because you are not doing the actual research at that point in time, but demonstrate you have the idea of what should be done with regard to sample.
If I said, for example, okay, and I'm assuming that we have like the population, the total size of the population is 100,000, and I use the tool, align tool, to get the sample size that fit our study, and I end up with 200. I mean, case this is not gonna be work. I'm assuming.
If you don't have a representative sample, what most researchers usually do, depending if you are doing like a predictive study, you might use PLSM, because PLSM can correlate, small sample, even as low as 30. You can maximize the explained variance on the endogenous sample, endogenous variables. So that's one of the reasons why you can decide to go for a PLSM, because it can maximize the explained variance, even with a smaller sample size. But for other statistical method, you really need a large sample size. So one of your reasons for choosing the research method might be because of the kind of sample you have. So you might decide to say, yeah, because if you have a smaller sample, you go for a research method that that can tolerate. And then another thing is, like, maybe if you are not sure of the type of data, maybe because usually regression, if you want to do regression, it is already presumed that you have a linear relationship in your data set. Normality, there has to be a normal distribution for you to do a regression analysis. If you don't have a normal distribution, assumption 1 is violated. Regression, no way. But PLSM can bail you out. You can use PLSM if you have a non-normal data, but it must not be highly non-normal. So these are like the reasons you usually provide for choosing a particular statistical method. So your sample has to be very significant. If you have a lower sample that is not up to a significant amount, you can decide to use, say, I'm using PLSM because I know that with this sample, PLSM will still provide, give a kind of accurate, of a higher validity, higher predictive validity, even with this sample size. So it's a matter of, you see, in this exam, demonstrate that you know what you are doing. Demonstrate that you know what you are doing, because you are not conducting an actual research, but demonstrate that you know what should be done. So provides accurate and thorough description of how the data will be collected. We mentioned the sample. You have to think about the population subjects, and how is it going to be surveyed. Of course, interview is out of place here, but sometimes they can collect a little of qualitative data. Maybe you want to kind of do a kind of triangulation of study, so you can do a kind of triangulation to understand a little side of what people are saying, So you have to demonstrate how you are going to, where is the population, where are you going to get a subject, how are you going to collect the data from them. Usually we go for survey. Usually we use the Likert scale type, which we will see briefly, about how the data should be collected. They'll provide accurate description. Okay, description of analysis plan, rationale for using specified technique.
Is it a quick question, Clement?
Yeah.
When we mention maybe interview, semi-structure or structure, do you advise us to give like an example of the actual question that you will ask?
Of course, the first thing you should do when you're answering a quantitative or qualitative research in a qualifying exam is to state your research question. You must state your research question, because from that research question we give an idea of what you are going to do. If it's going to be a flexible research or going to be a quantitative fees design, the research question have to clearly say where you are going. So you have to write down your research question. Sometimes it may be a situation that will require you to reconstruct. Maybe they give you a paper, a poorly designed paper that is based on quantitative and asks you to come up with a qualitative, or you're giving a qualitative and asks you to come up with a quantitative. So you should be ready and know what to do in whatever situation you.
So my question was like, if I say that, okay, I will be conducting semi-structural interview, for instance, and then I just give one of the example of those interview questions that I will ask, or you don't have to.
Not necessarily. You don't need to mention. You don't need to. You don't need to state the question you are going to ask, but you are going to provide the overall research question. That is what you want to address in that research. You don't need to begin to write questions. That will be for if you are doing the actual study. So and if you're writing research question, most times you have to consult literature to know how others handled the situation in the past. So description of the analysis plan, rationale for using specified technique, whether you are going for like a t-test, say you have only 2 groups. So I'm going to, since I have 2 groups, I'm going to use t-text and then look at the p-value to know where the difference lies, using ANOVA. So you have to give a rationale along with identification basis for reporting the key statistics,
Question, Clement, if you don't mind, interrupt you.
Yeah.
For the p-value, what would be the difference if we change it? Like usually is 5%, right? What?
Yes.
0.05. What would be the difference if we reduce it or will include it? Will make effect or no? Significant like changes or no?
Yeah, if you state the p-value is like an assumption of what you are making, that the sample population or the sample statistic will fall within this certain range. So it's either it falls within the range or it doesn't fall within the range.
And how do I know if it falls within the range or not?
Yes. So the p-value will determine, where the difference, lies. So if it's something that you state, the statistic that you state before, so having decided on your confidence interval, 0.95% confidence interval, and the p-value is 0.05. That's usually what is acceptable in social science, So it's either it is within this range or not within this range. Because if you like look at the graph, if we have a graph that is always at the center, the middle, and then that is where the p-value lies, and usually maybe at the tail of the hypothesis graph. So it must, whatever assumptions or whatever will be the outcome must fall within that particular region for you to say you have a significant relationship or you don't have. Like if you're using ANOVA will be able to tell you the p-value and the other statistics will be able to tell you whether the outcome is significant or not. So most of these things you do them with a software, but in qualifying exam, because our concentration is qualifying exam. In qualifying exams, you just need to mention maybe p-value is going to be 0.05. If the question requires you to do that, most times you don't need to, depending on the technique.
For example, in terms of reliability, so let's say would the effect on would make the result of the oh my god, so it's coming that will make the change to the result for the study or no? Like
there is reliability.
Yeah, like for example, if we conducted ANOVA and then we make the p-value is like 0.7 instead of 0.5.
No, it has to be 0.5. 0.7 is like you're going for 95% confidence. That is too high. That is too high. Usually what is acceptable in IX, which you see other researchers do, is use 0.05. Leave it as 0.05. Don't go 0.01 or 0.08
That's
or
like the
0.09.
standard 0.05. Okay.
Yeah. It's always 0.05. But sometimes they may not even require you answer, going to that length in the qualifying exam. So description of how these statistics will be interpreted. Yeah, clearly explained.
And I'm gonna leave now, Clement, because I gotta go.
All right, thank you. See you some other time. The statistical analysis reported appropriate. The question is answered clearly and demonstrate comprehensive understanding. Yeah, of the research method. So that is it. I need to like a bit speed up. Need to speed up a little. We need to speed up a little. Now, survey design, we may not need to just to peruse through this because it's not actually needed for a qualifying exam, but you like have to have an idea. For instance, the idea of using the Likert scale. If you're using a Likert scale, so design, know what you want to know, what are the variables, how will you measure the construct, behavior, attitude, demographics. A goal of the survey question, interpret the same way, and the respondents will interpret the same way. That's reliability, be able to respond accurately, be willing to answer, very necessary. Does the question require an answer? Can people accurately recall and record the past behavior? Or is the respondent willing to reveal requested information? Will the respondent feel motivated to answer each question? Which question structure is most appropriate? Maybe open-ended questions or close-ended question, partially close-ended. You have to decide. So and then use simple words. Ask one question at a time, choose few words as possible, use a complete consent, avoid bias, provide, time references, avoid asking respondent to make unnecessary calculations, avoid, know your audience. So check out that apply question format carefully, include positive and negative categories. Be careful with double negatives. Do not overlap categories. For example, 1 to 3, 5 years or 5 to, be sure there is a category for everyone. Use order. Assign words with numbers. 1, strongly disagree. 2, disagree. Yeah, very, very important because this is a kind of Likert scale type. Then avoid neutral if possible, because you're not sure of what neutral position means. Do not go over 5 categories. Do not ask people to rank either themselves or things, So these are other things you need to consider about maybe parts of your questions. Usually we use the Likert scale. So now we are going to go into statistical inference. I really need to be very fast. So see what we're able to cover if we can finish quantitative research, this night, and then go over to some other thing, because we're going to spend a lot of time, working on the past questions to have a feel of what it's. So guys, here we have statistical inference. I'm gonna make this bold, make it a little bit bold, okay? So I hope it's bold enough. Present to a meeting, make it a bit bold. Yeah, we have two different areas of statistics. See that we do the descriptives. Usually it is recommended you do the descriptives before you go into the inferential statistics. The reason being that you need to understand the kind of data you have. When you run the mean, the mode, the median, the standard deviation, the deviation is very necessary. You plug in your data into the descriptive statistics. Sometimes you need to analyze the demographics, and the descriptive statistics will help you, to do that. So usually, because you need a descriptive to know, well, use the scatter plots to know if your data is normally distributed. So it's good. So now the statistical inference. First of all, we have to, think about the hypothesis, the null hypothesis, and which says that no relationship, and that is where our interest lies. Usually what you are trying to and when you are doing statistical inference, to prove there's no relationship. So you have to begin from that point, that this person is assumed innocent until proved guilty in a court. So what you're arguing is that he's innocent unless data or evidence provided shows that the person is guilty. So there's no relationship, that the person is innocent, So, or the data, there's no relationship in the data set you have. So if your analysis is consistent with the null hypothesis, you conclude the variables are not related. And then you accept the null hypothesis, or so either you accept or reject it. So you accept the null hypothesis. So that's because there's no relationship. If it is not consistent with the null hypothesis, it means your data showed that it's a relationship, then you have to reject the null hypothesis because there is a relationship that exists, So your initial hypothesis was there is no relationship. Now you have seen there is a relationship. So the null hypothesis, even in the population where the null hypothesis is true, there is a chance that you may draw a sample where it is not true, 5% of the time or less. So that is why we select 0.05. You see it now? So we call it the p-value or the alpha value. There are also the essence. What we are saying in essence is that 95% confident, we are 95% confident that we have not rejected the null hypothesis that is true. Yeah, this is also known as confidence interval.
Climate.
If you wish to increase the confidence interval, you make the insignificant level smaller. Okay, yeah, Ibrahim, what are you saying?
Yes, sir. We trying to reject the what's that called? Not but hypothesis. We start to reject the null hypothesis. Then if we fail to reject, we go to the alternative. Is that correct?
Yes. Yeah, when it's either you accept or you reject the hypothesis. When you reject the new hypothesis, what it means that the alternative hypothesis stands. It means there is a relationship because you started by our usually focus is to say, the emphasis is on the null hypothesis that there is no relationship, assumed innocent. Now data says no, that he is guilty. Then you reject the new hypothesis that the person is innocent, and you either accept it or you reject it. So by rejecting the new hypothesis, what it means that the alternative stands. So
that's right.
So the confidence interval and level. So the p-value is very important, and established probability level, which serves as criterion to determine. It represents the confidence that your results reflect true relationships. So 0.01. I correctly reject the null hypothesis 99%. We don't usually go for. So we go for 0.05 in here. So we have the type 1 and type 2 error, false positive, and I know you know all this already, So the type 1 and type 2 errors. So here in type 1, correct rejection of the null hypothesis, that the statistics dictated a difference between the groups. There is a real difference. So but you make an error when you say there's no real difference between the groups, whereas there is a difference. So that's the type 1 false positive. The type 2 is it says dictated no, there's no difference. The first one is there's a difference, but you said there's no real difference. And the second one says there's no real difference, and yet you are not able to dictate it. That is type 2 error. You already know that. So there are ways to avoid this. Reciprocal relationship exists between type 1 and type 2. The likelihood of type 1 error decreases the likelihood of type 2 error. So the type 1 errors are controlled by adjusting the significance level. So type 1 error, to avoid type 1 errors, that's why we usually go for 0.05. And then for type 2 errors, significant sample size, ensuring good sample size to avoid the type 2 errors. And sometimes, if you are designing a research in qual, you might need to mention this. I have to choose a significant sample because in order to avoid it, to avoid a type 2 error, because you need a higher sample size, to avoid a type 2 error. And then, if a test has lower power, that is lower sample size, the researcher, might fail to dictate an effect and mistakenly conclude that none exists. So caution. Very large samples decreases likelihood of making type 2 errors, but might increase the likelihood of making type 1 error. So, and then finally, the test of significance, there is different statistical tests to perform to determine whether relationship between variables exists. The type of test used is determined by the type of variable you have, nominal, ordinal, interval, number of variables. And it depends on the kind of text of significance you have. So we already saw these charts, last time, which you have to use to decide on which statistical test to use. So that's all about statistical inference. Now we are going to begin with t-text. Usually t-text when you have only two groups. So let's run down quickly, and then all the things that we're just refreshing our minds on the things we already know. And so the t-text, this is still loading. Please load fast. Why very slow this time? Okay. So the t-test, the statistical test used to determine the differences between the means of only two groups. You have to put it in mind. If you have a research question, you're designing a question that only have to involve two groups. So mention that you have to go for t-text. I think that's the most basic thing you need to know about, doing t-text in a quantitative, qualifying exams. It's very necessary. So there are several types of t-tests: dependent samples, matched tests, and then most of these details are not needed for qualifying exams. So start with a null hypothesis that there's no difference. So then if the obtained t-value is less than the critical value, reject the null hypothesis. If the obtained value is higher or is lesser than the critical value, accept the null hypothesis. The software packages will give you a significant level determination. So if t is greater than 2, then it is usually statistically significant. So more on t-statistic, 1/3, one group is higher than the other. Look for words such as more, greater, better, or higher. In a 2/3, no directionality. This has to do with the kind of hypothesis. We have 1/3 hypothesis and 2/3 hypothesis. In a 1/3 hypothesis, there is like one direction, but there is going to be a positive effect. Then in 2/3 hypothesis, there is no direction, which means either it could be a direct or an indirect effect. For whichever way, you have to dictate the question. The question is simply, is there a difference? So, and then look at the example they gave here: making assumptions, making sampling random. Sampling is random. Yeah, we mentioned that already. A level of measurement is usually interval ratio for you to do. So that thinking about the kind of data you have. So the data must be at the interval or ratio level. Then sampling distribution is normal. It's an important assumption. And then stating the null hypothesis. So, and then the significance interval has to be, the p-value has to be 0.02 in the 2/3. So I think these are the most of the important things you need to know about. This is, the rest is what you have here is on the statistic you have to report if you are doing the actual study with the software. So we don't need to go into that. Yeah, so after the t-text, which has only to do with one group, with two groups, then you go into ANOVA. ANOVA, you have, when you have 2 or more groups, maybe 3 groups or 4 or more. So analysis of variance, also called one way, because each value is classified exactly in one way. Example, comparisons between gender, race, political, or color, conditions or assumptions. The data is randomly sampled. The variances of each sample are assumed equal variance, and then the residuals are normally distributed. Ibrahim, you're asking a question. Yeah. Now, before I discuss ANOVA, we have to think about, let's talk about regression first, because I have to follow it this way. We mentioned about t-text. We have to look at correlation. We have to look at correlation first, look at regression in that order, because it has we have to look at correlation first, and then regression, then before we go into the t-test.
That's right. Exactly.
Yes. Yeah. So correlation first, because for the correlation, in correlation, first of all, you assume there's no causality. You're trying to understand, because that's the way when you look at a flow chart, that's where, first of all, usually you start. Correlation is when you don't have a true independent variable. You don't have a true independent variable in the study, and you're interested in relationship between two variables, how this variable affected the other. So correlation is a single number, you know. We call it Pearson coefficient. Indicates direction, positive or negative, you know, positive correlation or negative correlation. You see the positive one here. All the data points are like in a straight line, you know. So positive correlation, the higher values of X are associated with the higher values of Y. Because when X rises, Y rises. Negative correlation, positive high values of X are associated with the lower values. X rises and Y goes low. So no correlation. X, you know, the values of S are not at all predictive of the values of, so there's no changes at all. No correlation. No correlation in the two, you know. So this is a scatter plot. Usually before variables are entered into the regression model, you know. So usually these variables might be texted in using a correlation matrix to understand if they really have effect. Because before you enter into any variable that you find in a regression model is an independent variable that, you know, have some kind of that has some kind of relationship with a dependent variable. So these variables are not entered arbitrarily. Usually in, you know, literature, you know, these variables are chosen based on previous studies. You know, previous researches has shown that there is a relationship between this variable and this variable, between this dependent variable and maybe between weight gain and calorie intake. You know, and they know that the dependent variable is always, most of the time, is always numerical variable at the interval ratio level. It's always a numerical variable, the dependent variable. But the independent variables are usually categorical variables. So in a correlation matrix, because this is a correlation matrix plotted in the variables, looking at the use a correlation matrix to display the correlation. And the variable is perfectly correlated with, say, if R equals to 1. Yeah, perfect value, perfect correlation. Sometimes you may take into account the effects of one variable they have on another. This is controlling for, that is covariates. Sometimes it happens though. So when you do not control a variable, it is called a zero order correlation. Most of these are not, you know, important details. So partial correlation attempts to find a correlation between two variables after removing the effects of other variables. It helps to spot correlations explained by the effect of other variables, as well as review correlations masked by effect of others. When you control one variable, it is called first order correlation. And we usually don't do that in correlation a lot, you know, trying to control for variable. We don't have the covariates when you're doing like ANOVA, you know, and the rest. So determining of the coefficient of determination, we have, look at this R square. We have this small r gives you the proportional variance in the fluctuation of one variable that is predictable from the other variable. It is a measure that allows us to determine how certain one can be making prediction from a certain model or graph. So the coefficient of determination is the ratio of explained variation of the total variation. So lies between 0 and +1. So it denotes the strength of the linear relationship, you know, +1 or -1 or 0. So that's the coefficient of determination, the R square. So the coefficient of determination represents the percentage of the data that is closest to the line of best fit. For example, if the R is 0.08, the Pearson R, then the coefficient of determination says it's like times 8 times 64, which means that 64% of the total variation in Y can be explained by the linear relationship between X and Y, as described in the regression equation. So the other 36 of the total variation of Y remains unexplained. I've mentioned earlier that why we usually use a PLSM is because we want to maximize. It maximizes the explained variance, because you need to know more. A good model should be able to have a very high predictive validity, high prediction, which means like 64. You have a 64 is, you know, you have a reasonable, but that it means that the variation if it's in a regression model, the variation in the dependent variable is accounted 64% by the independent variable, because you are manipulating the independent variable to see the effects it has on the dependent variable. So that's why it's the dependent variable is the predictor variable. Sometimes they call the independent variable the criterion variable. So it is the independent variable that you are manipulating to understand the relationship between. So if the independent variable was able to explain like 64% of the total, it's good. The UTAUT model have this level of validity, explaining when it comes to predicting technological adoption. We have up to 64% or more, with the UTAUT model. That means it is a very good model. So all the constraint entered in the model, makes the model parsimonious, can really explain what is going on there. Assuming you have only 20%, you have only 20% of total variation in Y, then the model is not accurate, which means there are other factors might be responsible for that unexplained variance, So this is all about correlation. Correlation is not causation. Most times in the qualifying exam, you are asked to do causal or non-causal study. Correlation does not go beyond explaining the relationship between two variables. Usually you are not sure which one is dependent and which one is independent, and it is just like a point you want to prove, a point of positive or negative correlation between, and this normality of distribution is always an assumption that is required if you are doing a regression. So correlation is, so if I'm like asked to do a non-causal study, if we in a non-causal study, I may decide to go for correlation study to understand the relationship that one variable, has on another. So I will just decide to do that instead of, since it is non-causal. But if you want to do a causal study, regression, PLSM, they are there. And then the ANOVA, Markova, and the rest, they're also there, because these are causal way. Because when you are doing experiment, remember we have different types of experimentations. We have true experiment, we have non-experimental, we have quasi-experimental. I hope you still remember these different types of experiment, because you have to decide if you are designing in a quantitative research study, in the qual exam, you have to state actually what you are going to do. You have to be very explicit to say, okay, I am going to take an experimental approach to understand this. And since I have more than 3 groups, I'm going to use ANOVA. Since I have only 2 groups, I'm going to use t-test. So you have to really state which methodology you're going to use, what kind of payment. Okay, because I cannot be able to randomize, given the situation, I will go for a quasi-experimental. There's no random assessment, a random assignment of subjects to different groups. So that randomization is not there, but the manipulation is there in a quasi-experimental. So what makes the true experiment different from quasi is random assignment. So correlation doesn't go beyond explaining the relationship, between two variables, degree of relationship, direct or inverse. So it might be good for when you are doing a non-causal study. Any questions so far? Now, having seen correlation, the next thing should be regression, because that follows now. Regression, we have multiple regression, we have bivariate, when you have only 2 independent variables. And if you have more than 2 independent variables, then it might be multivariate. Yeah, you have more variables. So usually if you're doing a multiple regression, remember that PLSM is an ordinary least square regression. It's an ordinary least square, so it's a kind of regression, so to say. So they are related, and some of the assumptions, though in the PLSM, there's no assumptions. You don't have, but in regression, you have to do some assumptions. So it requires interval and ratio level, the same thing that is required for t-text. So interval and ratio data can also be dichotomous, so true or false, male or female, and then ordinal data. If you have ordinal data, they can be coded. You see if the data fits the model of the regression. It is wise to conduct a scatter plot analysis. You see, which is a kind of descriptive reason. The regression assumes a linear relationship. If you have a curvy linear relationship, no relation, regression analysis is of little use. So this is some of the assumptions you need to make. Look at the type of lines. Which one is more positive? You have this. So this will be good for regression analysis. So you have to plug in your data into a scatter plot. All these things are done with software and see if you have a linear relationship. If you don't have a linear relationship, then you might decide to do PLSM. Say because one of the reasons for the choice of PLSM is because data is not normally distributed, but it should not be highly non-normal. If you have this kind of thing, look at what we have here. You can't even do PLSM. In fact, no statistical method will tolerate this. You see, no statistical method will tolerate this because this is highly non-normal. There's no shape in this data, nothing at all in this data, shape. Which means there is, sometimes when we talk about validity and the reliability, we usually use these people who do, like you're trying to target, or people who use the anchor, to shoot at the target. Usually at the target, at the center of that target is the accuracy. Reliability is how far it is closer to the center of the target. Do you understand what I'm trying to say? Like people who are using who play in the anchor, who use we see the archery, we call it like a kind of archery, people who use who shoot at the target, so when they use their anchor to shoot at the target. So if you shoot at the target, the center of that target is the point of validity. Reliability is how close it is to the center. So if you shoot at all the shootings, all the data set is pretty much closer to the center, and they are closer, so it means there is some reliability in the measurement. But if they are all scattered from the center, which should be the point of accuracy, then it is assumed there's no relationship. The data has no shape. Still, have one dependent variable, which is and more than one independent variable. Yeah, multiple regression. So basically, you are asking two questions. How well do the independent variables predict the dependent variable? That's two questions you answer. You're asking a regression model. And then which of the independent variables were most significant predictors? So the first is how collective, how collective, the linear combination of all the variables, how well do they predict the dependent variable? And then which among the variables, is the most significant predictor or predictors? Two questions, you answer in regression model. Keep it in mind. So in bivariate, unstandardized equation, dependent and dependent, and the constant regression equations. Most of these things you do in actual software, regression equations, multivariate or standardized. Usually they will ask you to use standardized coefficients, bivariate equation dependent, standardized regression coefficient. We are going to, now the next thing is, according to the charts, the chart says what kind of statistics you need to report. And that's what we are looking at now. In order to answer the second question, in the multiple regression, which of the independent variables are most significant predictors, we need to look at the t and the beta values. Have it in mind. B ranges from +1 and -1. The larger the absolute value, the stronger the predictor. So the sign only tells you the direction, direct or inverse. So you report the T statistics and the B for the most significant predictor. And then for the combination, So the sign tells you the direction. Okay, no data is, so the SIG-T is always 0.05. Then the variable is a significant. Okay. If the SIG-T is 0.05, then the variable is a significant predictor. So report the T value, the SIG-T, and the beta for deciding on which of the dependent variable is the most significant predictor, or which variables, independent variables, are the most significant predictor. So if T is 0.05, then it's a significant predictor. So you have to report T value, SIG-T, and B. So you have to mention it. Even if you're answering question in the midterm, in the final exam, in the qualifying exam, they will always ask you to report the statistics. So for the first question, which is how well collectively, you have to report the F statistics or the R value. So the F test determines the significance between the dependent variables and all the independent variables. If SIG-F is less than 0.05, then you have a significant relationship. So it is almost like the same value for the T and also for the F, you see, for you to have a correlation. So we have the R, which is called the multiple R, multiple coefficient, correlation coefficient. Remember, we made the coefficient of determination in correlation. That is the R squared, the small r squared. Here we have a R squared again, which is a multiple coefficient of determination. The other one we saw in correlation is coefficient of determination. Here is multiple coefficients of determination. It's a capital R squared. You have to note this because sometimes people confuse it. We have the Pearson R, which is a small r. We have the small r squared, which is a coefficient of determination. We saw it in correlation. In regression here, we have the capital R squared, which is a multiple coefficient of determination. It ranges from 0 to +1, almost the same thing, the same values, the way it is in correlation. So it tells us the percentage of the dependent variable that can be attributed to the independent IVs. How successful were the independent variables at predicting the dependent variable? You have to report the R square. You have to report the R square, the T, the SIG-T, the beta, then the F text, the F stats, and then the R square. We have also, okay, it says here, so the R square, the percentage of, what percentage of dependent variable can be attributed, changes in the dependent variables can be attributed by the independent. That's what the R square, the multiple coefficient of determination requires. In qualifying exam, you may need to mention these statistics you are going to look at, So the larger sample usually produce smaller R values, and vice versa. So you use the 10 times rule where the number of reported IVs, number of variables you have. So R square tends to somewhat overestimate the success of the model, and because of that, we go for the adjusted R square. Gives you the most useful measure of success for the model. Don't forget the adjusted R square. So you see all the statistics that you need to report, So to recapitulate again, to recap again, to understand how well collectively, all the independent variables predict the dependent variable, you report the beta value, you report the T statistics, and also you report the SIG-T. So you report the T value, the SIG-T, and the beta, just to understand how much all the linear combination of the dependent variables predicts the independent variable predicts the dependent variables. Then when it comes to understanding how each of the variables, which variable or variables are the most significant predictor, we report the F and the R values. Look at the F and the R values to understand how collectively the independent variable predicts the dependent variable. So this is for the first question. the collective. There's first, the second one here is for, to determine. We report the t-value, the sig t, and the beta value when you want to understand, how well, which, independent variable is the most significant predictor. To understand the most significant predictor, most significant predictors, you report these three values, t value, sig t, and b. I'm repeating it because I want you to stick, and then when it comes to the how collectively, all the values, you report the F statistics, and the F assume the same value with the T, with the T you have here, almost the same value, 0.05, which is usually our p-value. So the F, you have the F, and you also report the R value, the F and the R statistics. So the R, first of all, the R square, you have to report the R square, and also you have to report the adjusted R square, because it says here that the R square tends to overestimate the success of the model. So thus, the adjusted R square value is calculated, which takes into account the number of variables in the model and the number of observation participants in the model is based on. Yeah. And I hope you understand the independent variables, how they are measured. Each of them are measured with a question. They are measured with a question on the surveys, on your survey design. These questions are usually the scales we use in measuring. They are usually Likert scale type of questions with an anchor, either plus, strongly agree, or an anchor, maybe 1, strongly disagree, and 5, strongly agree. There's always an anchor in a Likert scale type. So sometimes people wonder, how do we measure? How does the independent variable, how do we operationalize it? These variables are operationalized already. So to measure a variable, you have to look at literature to understand the scales. And then if you have applying it to a new context, you might need to adapt the scale and then do a pilot text before you do the actual research, before you do, So make sure you have reliable measures. Reliability and validity, they're very important. There are other types. These are the basic information you need at this point about regression, the t-statistics and what you want to understand, the 2 level of questions you ask, and then the statistics you need to report, So based on the statistics, you'll be able to say, look at what you're able to observe in your data. So you do the analysis. There are other different types of multiple regression, the hierarchical. For somebody's going to ask you all this in the qualifying exam, but for the sake of clarity, we mentioned them. Types of regression: hierarchical, first, and then hierarchical known predictors are based on past research, So you put them on hierarchy and enter into the regression model first. So key known predictors are entered first in the model. So new predictors are then entered in separate step block. Experimenter makes the decision based on theory testing. See the unique predictive influence of the new variables on the outcome, because known predictors are held constant in the model. So relies on the experimenter knowing what they're doing. So we have a first regression. All variables are entered once, regardless of the significance level. This is first. So remember, the first one is based on theory, hierarchical. So also standard or simultaneous regression. Results obtained depend on the variables. How many of which ones you entered in the model. Important to have a good practical or theoretical reason for including every variable. So it's always based on theory. So types of regression, we have free entry. All variables are entered into the model simultaneously. And then when none is possible, additions can make the statistical significant improvement in R, then the analysis stops. So it's a free entry, and then forward, can read up the rest. We've gotten backward, stepwise, try everything. Then multicollinearity. Multicollinearity has to do with the relationship between the independent variables. When 2 variables are measuring almost the same thing, there's no difference. That is a multicollinearity. Combined effect leads to unstable coefficient depending on the dependent variable model. So always exists. It's a matter of degree. Example, using both total number of rooms and the number of bedrooms as explanatory variables in the same model. It is just usually the same. When 2 variables are measuring almost the same thing, so you have a multicollinearity. And then it has a measure, higher correlation between independent variables, 0.080 or more. So dictating multicollinearity, use the correlation matrix and look at the correlations between the PIVs and more than the DVs. Yeah, because looking at the IVs mostly, IVs that I have are 0.85. Use the tolerance value in the SPS printout. The tolerance is the portion of the variable not associated with other variables. So tolerance equals to 1 equals to R minus R squared. So this is dictating the tolerance level, helps you in dictating multicollinearity. So you just need to mention, we have to measure, I have to ensure that the variables, there are no multicollinearity among the independent variables. This is what you need to mention, like in an exam context. You may not go into all this description, but understand that you have to mention it, So dictating multicollinearity, like a larger tolerance, the better. As long as the tolerance is less than, greater than 0.030, the variable is okay to use. Zero tolerance is bad. Tolerance near 1 tolerance is good in terms of independence of the predictor. Deals with independent variables. So multicollinearity is with independent variables and not with the dependent variables. So this is under SPSS, So look at the VIF here. The variance inflection factor, the constant, the tolerance level here is 0.05, 0.5. So it says here that 1 over tolerance is VIF, whereas the higher it is, the greater the multicollinearity. No multicollinearity, the value of equals 1. If VIF approaches 10, that means about 10% of the variance in the predictor in question is not explained by the combination of other predictors, must deal with collinearity, So detecting ways to multicollinearity, obtain new sample data. So obtain new sample data, eliminate one correlated independent variable, or combine the variables. Do 2 runs, one with each variable. So this multicollinearity also applicable, not just when you are doing regression, but also when you are doing PLSM. We are also going to see it, that you need to deal with also multicollinearity. Either you combine or you remove them. But whatever you have to do, the decision should be based on, because sometimes you remove one variable might affect the content validity of the model, So it depends on if you should leave or not. The decision has to be based on, based on literature. So this is doing this in SPSS. So weak, moderate, strongly, and then strong. Interpreting the R square. Multiple coefficient of determination. Reasons for low R, missing data, inadequate responses, reliability, problems operationalizing the variables. So that will lead to low multiple determination. So missing data, inadequate response. You also deal with these things when you are working on PLSM model. So missing observation, suppressor variables. As variables enter the regression equation, the predictive power of an individual variable decreases. So if a new variable enters the equation and the beta rises, then the new variable is called suppressor. When a suppressor is controlled, the relationship between the two variables increases. May use free entry, backward regression to address this issue. Missing data can result, too many missing data are always a problem. Make sure to tell SPS what to do with missing data. Options for missing data: mean substitution gives you the mean of the variable of any missing. Best choice, listwise, removes any one who left out one or more variables from the entire analysis. So all these things are done within the SPSS. Pairwise deletion only removes person from particular variable. Different n of each variable. No one is ignored. The correlation coefficient is calculated based on the number of people who answered both the questions. So all this is done in the SPSS. Deal with the missing observations. Dummy variables. We call this dummy variables. Variables like they are usually categorical values. We assign values to them. School, political party, etc. Dichotomous variables. We have 2 choices. Male, female, employed, unemployed, male, true, false. Change coding, to 1 and 2. So if you have 2 choices, like you have a male and female, you might 1 for male, 2 for female. whichever way you want to do it. So you have to do the coding. So, and the categorical variable, make sure each group of new variable you code, one, use two. So you code dichotomous variables, 1 and 2, and be consistent in doing so. So this is 8:33. So we take a little break again, and then we continue by 9 p.m. Hello guys, are you there? I can't see anybody. I can't see anybody. I can't see anybody. The videos are turned off. I don't know who is there. Who is there? Hello? 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 Nobody is here again.
Okay, you did good.
Yeah. So we have ANOVA, analysis of variance, and we use analysis of variance when we have two or more groups. So the t-test is when you have only two groups. When you have more than two, groups. And the ANOVA is good in when you are doing experimentation. Experimentation, because one of the assumptions that needs to be satisfied before you do ANOVA is there has to be equality of variance between the different groups. So if you want to do a true experiment, you can use ANOVA to do experiment because you have groups. You have two or more groups. So, and then like in regression, you always have independent variables and dependent variables. And the number of independent variables in the model will determine, what's the kind of ANOVA you are doing. And for each independent variable, sometimes called a factor in ANOVA. Each factor has. Can you hear me?
Yeah. So when we do the experiment study, we should have a treatment and control, right?
Yes.
So in ANOVA, when we do different group, we used to, you know what? Never mind. Go ahead.
Yeah. Let me go ahead. Yeah, we are going to see some examples that will answer the question you have in mind. I understand where you are going. So we have, you can have like two groups, maybe treatment, no treatment. This, that's an example they gave here with, students. Assignment group. There is an assignment group, a no assignment group, an 8 weeks assignment group, a 16 weeks assignment group. So, okay. So now let me continue. Okay, analysis of variance. Okay, so ANOVA tests the following hypothesis. The means of all the groups are equal. Usually, the focus is on the null hypothesis. The neutrality hypothesis, all the means are not equal. So it does not say how or which one differ, which of the group. You can do follow-up multiple comparisons, post hoc tests. Note that we usually refer to subpopulations as groups when you are doing ANOVA. With the factorial way, it's one way ANOVA. You also have one independent variable, which might have levels. Can you give me an example of an independent variable that might have levels? We have like education, right? If you're doing education can have up to 4 levels, right? High school, college, high school, college, graduate, undergraduate, and graduate.
Yeah.
These are 4 levels. So when you like to see education, understand the impact of maybe salary, so the impact of maybe the voting, and want to see across the population of students, the voting performance. So you're examining the voting performance across a student population. So when you mention like a student population, you have to define which levels of the student are you talking about. Is a student, because there's something like in ANOVA, there's something like a student in general. You have to be very specific. So that is the levels you have. Education, which levels of education? Students, which level of students? So call the multi-way. So call the multi-way or n-way analysis of variance. You can also have 2 independent variables, and then 1 DV. And then, so look at the notation here, which means you have 3 independent variables. One has 2 levels, another one has 3 levels, another one has 4 levels. So that's the explanation here. Then, so why use factorial ANOVA? Why not just multiple one-way ANOVAs? So increase power. With the same sample size and effect size, a factorial ANOVA is more likely to result in the rejection of alternative hypothesis. With equal size effects and probability of rejecting the hypothesis, it is true alpha, you can use fewer subjects and time and money. With the 3 IVs, you need to run 3 one-way ANOVAs, which would reflect your alpha level, which is not known. So the best reason is that a factorial ANOVA can dictate interactions sometimes that multiple one-way ANOVAs cannot do. So the factorial ANOVA is a one-way ANOVA best because it can help you to understand whether there is an interaction effect or not, instead of doing multiple one-way ANOVAs. So the interactions, usually that's the first thing we look at, the interaction between the independent variable and the dependent variable, the different levels of independent variables and the dependent variable. So when the effects of one independent variable differ according to levels of another independent variable. Example, if testing 2 IVs, gender, male and female, as gender has 2 levels, male and female, and age have 3 levels, young, medium, and old, and their effect on performance, effect on performance. So if males' performance differ as a function of age, that is, males performed better or worse with age, but females' performance was the same across all ages, we would say that age and gender interact. Age and gender interact, or that age and or we have an age, times gender interaction. That is if male performs better or worse with age, but females was the same across all ages, we would say that age, interact. There is an interaction. So the age has an effect, with the gender. So there is an interaction within age. So because for men, they performed better, with age or worse with age, and for female, female performance was the same across all ages. So we say there is an interaction. Generally, the question of interest are hypotheses to be tested concern 3 questions regarding the potential effect of variables or factors on the response variable. That's the questions. Number 1 question is, do the effects of A and B, have on the response variable interact? That is there a significant interaction between factors? That is, the independent variables are called factors in this model, in ANOVA model. So, does A and B interact? Like we have gender and then age and gender. Do they interact with regard to performance? And the performance is the dependent variable, which is usually an interval ratio variable, a numerical variable, always a numerical variable. So those are the interaction effects is what you're going to look at. Do they interact? So if you conclude that there is an interaction between the 2 variables, then it is significant. And when there is a significant, there is no need to consider the independent effects of each of them. But when there is no interaction between the 2, then you have to look at them. You look at them separately. So if there is not a statistical interaction effect, then we can consider the main effects separately. So the interaction effect and the main effects. Question, does factor A alone have effects on the dependent variable and the B alone does it have? So these are the same. Remember in regression, we have 2 questions. First question is, the most significant, which among the variables in the model, is the most significant predictor or predictors. Remember that. And then for that, you report the key statistics. And then the second is how well, the collective combination of all the variables have effect. So these 2 questions. So for ANOVA, it is the interaction effect and also the main effects. So the interaction effect, the first question. If there is no interaction effect, then you look at the main effect separately. So 2 questions that needs to be addressed. This is the ANOVA table, the tail area, the p-value. So the focus here is the p-value. Is there an interaction effect? So if the interaction is not statistically significant, the p-value is greater than 0.05. We conclude that the main effects, if present, are independent of another. So it's not significant if the p-value is. So you have to keep in mind the p-value when it is greater than 0.05 with ANOVA. So we then test for significance of the main effects separately because they are not significant because the p-value is higher than 0.05. So then for the main effect, we look at the f-test. Remember in ANOVA, when we're doing regression, the f-test comes in when we are, f-test is when you are looking at them, when you're answering the second question, which is the collective combination. When you are looking at the collective, how collectively, the linear combination of the variables, contribute to the predict the dependent variable. That's when you look at the f-test. You can see f-test also comes here again. But here in ANOVA, f-test is testing separately, the main effect separately. In regression, it was a combination of what the variable, that's when f-test comes in. So sometimes all this can be very confusing. Abraham, are you there?
Yes, sir.
Yeah, so this is can be very, one text means one thing in another.
Okay.
Yeah, it means a different thing in another. It means one thing in one and then a different thing in another. So that's why sometimes I try to draw these comparisons, compare two and then see so that it becomes very clear in your mind. So if a main effect is significant, then use multiple comparison procedures as usual to compare the mean response at different levels of the factor. So if for instance you say that age is significant, as when you examine the main effects separately, then you can check the different levels. Use multiple comparison procedures to compare the mean across different levels, and then maybe age, maybe low, medium, and high age. Depending. So if an interaction is significant, the p-value is less than, then we conclude that the main effects are not independent of one another, and that's both effects are important. That is if the interaction is significant. In this case, the interaction is significant. The test for the main effects in a two-way ANOVA table are meaningless. Once there is an interaction, there is no need for examining the main effects separately. So in this case, the interaction is significant. The test for the main effects, is meaningless. Summary: these ideas can be extended to more than two variables. Anyway, so when interaction exists, the main effects involved are important, but cannot be discussed separately. Multiple comparison can be still conducted to compare the different treatment level means. I hope this is very clear. ANOVA is very clear. So this is the descriptive statistics. The descriptive based on the data they provided. Then analysis of covariance. Yeah, analysis of covariance, which means here we have a covariance, and a covariance is usually a variable that have a relationship with the dependent variable, which means that a variable that have an effect on the dependent variable, and if this effect is controlled, needs to be controlled or might be controlled, to obtain certain level, understand the level of variance, because it is something that could affect, if it is not controlled, the effect of that variable might be very significant on dependent variable. But assuming we say, maybe we ask ourselves, what is a covariate? Because sometimes it's very clear to understand what is, a covariate in research. So what is a covariate in research? So a covariate is a continuous variable. You see, it is a numerical, it's a continuous variable, that is expected to change, that is vary with, the outcome variable in a study. Generally speaking, a covariate can refer to any continuous variable that is expected to correlate with the outcome variable of interest. There has to be a correlation, with outcome, with a dependent variable. Otherwise, it will not be a covariate. We're going to see example. What is ANOVA? ANOVA is an extension of ANOVA, in which the main effects and interaction are assessed on the DV scores. After the DV has been adjusted by DV's relationship with another covariate. Yeah. So extension of ANOVA, the main effects and the interaction effect are assessed by the DV scores. You assess it, after the DV has been adjusted by the covariate. A covariate is a variable that's related to the DV, which can manipulate, but you want to account for its relationship with the DV. Which you can't manipulate, but you want to account for its relationship with the DV. Minimum number of CVs that are uncorrelated with each other. Then CVs should also be uncorrelated with IVs. Yes, it must not be correlated with IVs. Example, the CV should be collected before the treatment is given. Should be collected before the treatment is given in order to avoid diminishing the relationship between the IVs and the DVs. I hope this is very clear, from the way I'm reading it here. So first of all, you have to collect the treatment. Before you apply, the CV should be uncorrelated with the DVs, yes. And then it should be collected before the treatment is given. Because why? Because if it is not collected before the treatment is given, because this is a continuous variable that have an effect on the dependent variable, you may not be able to understand, the variations that occur in the DV, what accounts for it, what accounts for the differences in the dependent variables, if this is not controlled. So it should be collected before the treatment is given. After you have done that, apply the covariate, then in order to avoid diminishing the relationship between the IVs and the DV. Yeah, why you call about diminishing it? Because if you leave the covariate there, the effect of that covariate might diminish the effect of the CV, such that you may not know whether the independent variable actually accounts for the difference you're observing, because there is some other factor. Can we find an example of a covariate? Something that let me see if we can be able to find an example here. For basic ANOVAs, effect size is shown below. No relationship, moderate relationship, and then strong relationship. What would it look like with a covariate? Okay. And then you say extends ANOVA with a significant group differences on the DV while controlling for the effects of one or more covariates, incorporates both ANOVA and multiple regression, allows for greater sensitivity than with ANOVA under most conditions. Only difference between the ANCOVA and regular multivariate is the language used. Multiple regression is the language used to describe the results. Controls for takes out partial the effects due to the covariate and sees if there are differences in the group. Yeah, we are still going to get an example. So, and then primarily concerned with reducing error variance and increasing power. When used appropriately for experimental setup, like what I said, experiment, it will do this. However, there is essentially no adjustment of means because due to random assignment, the groups are equal on the covariates. Groups, equality of variance. No adjustment of means, equal means due to random assignment with the groups. In other words, the effect size D is still the same. When to use it, experimental design. Bros, here is where you need to pay attention so that when you are designing the research, when you're answering the question in qualifying exams, you will deciding on the right statistical method, already makes the way for your success. Use the wrong experimental design, you mess it up from the very beginning. So ANCOVA is best used for experimental design to reduce error variance. You manipulate the IVs, random selection of subjects, random assignment to groups. That's why it is experimental. Use ANCOVA as a follow-up to significant maneuver. Conducts on each DV from a significant maneuver with the remaining DVs used as covariates in the follow-up. That is when you use it as a maneuver. However, a question you need to ask yourself is, why are you interested in the unified output if you are doing a multivariate analysis? It can also be used in quasi-experimental, but this is controversial. So don't use it don't use ANCOVA for quasi-experimental. It is very controversial. intact groups, because students are intact. That is why it is quasi. There's no random assignment. Students taking multivariate stats across states may not be able to identify all covariates affecting the outcome. Covariates will have some correlation with categorical predictor, So in SXS, look at it here in SX. You define your dependent variable, the fixed factor, then the covariate. So the covariate is self-esteem, which means self-esteem might have, it's a continuous variable and it is operationalized here, affecting, what is the dependent variable? Positive words. So positive self-esteem can affect positive words. So sometimes you might decide to check how a variable, might affect positive words. What are factors that could affect positive words? So if you need to understand the influence, how strong the effects of other factors have on positive words, you might need to control self-esteem. Because maybe the more the self-esteem, the more the positive words, or the less the self-esteem, the more the person might not be able to, be more positive in his or her words. So that's what means controlling out, partialing out the effect. Like what he said, you have to, before you administer the treatment, first of all, apply the covariate. Understand what the effect of that covariate on the dependent variable. After you have dictated the effect, then you control it, which means kind of partial it out, remove it, a sort of hold it constant, and then administer the rest of the variables. And then you can compare and see the differences. Okay, examples are coming. I know, Abraham, you may not have these slides I'm sharing. That's why you may not what I mean.
John Hilton, right?
Yeah, you may not have gotten it from the class you took, So, but you have it on the drive.
I already have the material, man.
You have the same material. Did you take this class with Juni Hilton?
Yes.
Oh, beautiful. You could miss you went through a very good tutor. So,
yeah,
so you're lucky you.
Yeah. I did take this material with her.
Oh yeah, beautiful. So we have the same materials. So so what we're doing now is like refreshing our mind, Most of these things, like we're discussing it now, it is sticking. So look at the independent variables here and look at the covariates. And then look at the factor. We have level of education, high school, college degree, or graduate. Okay, they didn't mention the undergraduate. So they use those 3 levels for level of education. And then, so level of education have direct effect on the test score. But there is some other factor that affects the score, which is also a continuous variable. Number of hours you spend studying.
Yes.
So you have to, in as much as you are in high school or college or graduate, your test score could be affected by the number of hours you spend. So, but you might decide to say, okay, we are not interested in looking at the number of hours. We hold it constant. We simply check what's going to be the test score result. Perhaps one could say that high school, a graduate might score more, might score more because of level of education, might score more. So you can, so what it says here, before you administer the treatment on the high school graduate, administer these exams to collect the test score, you might need to check the number of hours. Apply the number of hours to understand the difference that this covariate have on the test score, then partial this covariate out, remove it, hold it constant, and then apply this manipulates these independent variables that to see, maybe through conducting some kind of standardized exams or testing to understand the test score. Because if you don't remove this, it might affect the outcome. So, but if you control this, then you can be able to know if actually being a high level of education really affects, because you could be surprised to see that a graduate and a high school might even score more than a graduate. You may not be surprised, But so when they put the number of hours they spend preparing, it can make a whole difference. So one way ANOVA is only one dependent variable, one IV. Two ways, one dependent variable and two IVs. So this way is always determined by the number of IVs. N way, the factorial way, you have one DV and then 3 or more IV. Then you call it the N way when you have 3 or more. Two IVs, two way, one IV. Then ANCOVA is one way plus one control, two way plus one control, and then 3 IVs plus one control. I think it's very easy and very clear. Oh, this is the end. I'm doing a slide share. So, bro, I hope ANOVA and ANCOVA is very, very, very clear. You know. So
to be honest, I need to get back to those slides more over and over and over again. I need to get back.
Yeah, you might need to go back to them again and again, look at them again and again.
Yes, sir.
Yeah, it will make greater improvement because it's been a long time you took this class.
Yes, see, it is 5 years ago.
5 years?
Yeah.
Oh, you mean I've been in CGU for 5 years? Wow.
No, 6 years.
Yeah, but this program is 7 years maximum.
I want to tell you something. When I just enrolled in this school, these classes wasn't the qualifying exam classes. You know what that was? The qualifying exam was database, networking, software development, and something in management. Those was the qualifying exam, which is actually related to my my major. I'm computer. But this small mainly management information system is not computer information system. This is different from what I did study my entire life.
Why not? But because you are putting you through the stress of qualifying exam because you want to get a PhD. Had it been you stopped at master's?
When I just enrolled at this school. They didn't tell me this is the role, the core of the major. I told you. They told me the core of the major is networking, software development, and database, and management. Some of the management. That is my major's core exactly. This is management information systems core. There is nothing related to computer. This is management.
Yeah.
It is not computer information system. This is management information system. And it is what it is, man. Now I'm not gonna argue with the school.
Yeah.
Is that correct or not? I have no right to say that. It is what it is. I keep saying. Now, a lot of people that I have met from my major, they don't know nothing about programming. They don't know nothing about database. They don't know nothing about software development, and they become PhD.
Yeah, but I've taken all those classes, you know.
People, they don't know nothing about computer.
I've taken all those classes.
Don't study that. They don't study programming. They don't study database. They don't study networking. They don't study nothing. And
if you have a master's level, if you are doing master's level will prepare you a great deal. Like you learn software development, you want to be a software developer the rest of your life and make money through it. After taking the master's, taking the classes in your master's level, I think the master's level prepares you for that kind of industrial experience. If you decide to go further with PhD, learning all this statistical method and all this research, you are preparing yourself not just to work as a software developer, you are preparing yourself for something higher to teach. Understand? You hire to teach, and going for PhD means you want to teach, you want to research.
I teach my major in you're gonna be a doctoral in your major. This is MIS, not
Yes.
computer information system. This
But
is
if you are working,
information system.
what I'm trying to say is, if after getting your PhD, you are still working as a software developer in a company, they are still going to pay you as a software developer, like someone who, like in the same salary category with someone who did a master's.
Climate,
Because
I'm not gonna argue.
basically, yeah,
There's some people here become a doctoral, they don't know what's different between while and for. And this is, what is that? My computer information system and technology, which everything related to computer, which save data, retrieve information from certain place using programming, database, whatever, warehouses, whatever, that is the measure. Now we have cloud, we have a lot of theory from our measures, we have a lot of, but this is management information, MIS. People, they don't know programming, they don't know database, they don't know networking, they just join from what? From political science to this school and become doctoral. And they study what? They teach what? Information system and technology.
Yeah. That's why they get doctor, because they want to teach, they want to research.
And they become better than us. If you ask them what's the difference between while and for, they're not gonna answer.
They're not interested, yeah. Like when I graduate, I'm not interested in working as a software developer. Understand? I cannot work as a software developer.
What's your measure?
I cannot work as a software. My major is IT innovation. IT innovation, and I'm looking at my dissertation. I'm working on on flexible learning, e-learning, digital pedagogies and the rest. How technological affordances can contribute, to flexibility in learning. That's like an area I want to. You have to measure in an area you have interest. And my area tomorrow, I may not be working as a software developer, but being a doctor means you are knowledgeable, on what might be needed, in any area you find yourself. If you are teaching, at least you make references to things you know. You don't need to be a professional full stack software developer. CGU will not even prepare you, enough to be a full stack software developer. You have to work extra on your own accord. Have to make extra after taking the classes.
That's all in CGU. That's all in CGU.
Yes.
But
after getting the fundamentals.
Look at this. You contribute your dissertation with the new algorithm, with the new new apps. You use your knowledge to just come up with something, help people in different area like informatics.
But you must have theory.
To be very professional in database, yes. You be very professional in programming, you be very professional network. Those people that I study with, they don't know all of these things. They come from political science and they become
yes, I
doctoral.
know. Yeah, even if you want to contribute to a new algorithm as part of your dissertation contribution to knowledge, you must have a theory and you must do real research. You have to collect data.
I understand. Yeah. But that is what we call the supporting material, is not core material. Supporting material means something need to learn to become a doctoral. That's not your doctoral, measure. This is from other measure. It's from management and information system measure. You could use it even from other measure, but it is not my measure. Clement, I'm not arguing you that CGU right or wrong, but I become in a situation where I start from scratch to learn something new.
Yeah, it's always something new for me. I'm a priest. I did philosophy and theology. Then I came to this country, went into systems engineering at LMU. It wasn't easy for me, moving from arts, humanities, to the sciences. Found myself in the Civil College of Engineering, did masters in systems engineering for 2 years. And then came over to CGU and then started afresh again. CGU was like beginning afresh. There's no kind of continuity between the systems engineering and the IS field. So
I was trying to just study statistical. I don't know. It's optional course. I was trying to. They told me you don't need it.
okay. So let's progress. We have the t-test versus ANOVA versus MANOVA. You know, and the number of independent variables is 1 on the t-test and then 1 on independent variables. Then the ANOVA and MANCOVA could be multiple independent variable, 1 dV. Then MANOVA and MANCOVA, multiple independent variables, and then multiple dependent variables. So MANOVA, multiple analysis of variance. MANCOVA, an extension of ANOVA and MANCOVA respectively. Both examines the mean difference between one or more independent variables and on 2 or more dV. So additional dVs now is what is the difference. In ANOVA and MANCOVA, you have 1 covariate, but here you have more covariate. You have more, you have 1 dependent variable here, ANOVA and MANCOVA, but here you have 2 or more dependent variables. So MANCOVA controls for 1 or more extraneous variables, just like an ANCOVA, with covariate. So examples. Are there significant difference between Caucasian, 1, African American, Hispanic, with regard to overall GRE scores? Independent variables here: Caucasian, African American, Hispanic. Dependent variable here: GRE scores, quantitative, analytical, and verbal test. 3 dependent variables, 3 IVs, 3 dependent variables. MANCOVA, then controlling for the effects of financial status: 1, parent education; 2, are there controlling the effects of financial status and parents' education? Controlling, that it means the covariate, financial status, parents' education. Are there significant difference between Caucasian, African American, Hispanic, which are the independent variables, on multiple dependent variables, which is quantitative, analytical, and verbal? Is it very clear?
Yes, sir. I just told you. Back to one.
Yeah. So once it hears controlling the effects, it means they are the covariates, the MANCOVA. So one-way maneuver example, you have one-way maneuver, 1 independent variable, 2 dependent variables. Test score and annual income determined by the level of education. Then two-way maneuver example, 2-way, 2 independent variable, then 2 dependent variables. I hope you understand the arrow. The arrow is very clear, each pointing to the 2 dependent variables, each factor, and the covariate. And okay, each factor, we have 2 factors here, no covariate here. This is MANOVA. And then we have MANCOVA, so we have 1 independent variable here, with how many factors, many levels, 1, 2, 3 levels. We have a covariate, number of hours spent studying. We have 2 dependent variables. Okay, number of hours spent studying. Then we have test score and annual income. These are the MANCOVA example. Advantages of MANOVA and MANCOVA: allows for the examination of multiple DVs. You have multiple dependent at once without need to conduct ANOVA and MANCOVA tests. Protects for inflection of type 1 error. ANOVA was reduced error variance. Here it protects the inflection of type 1 error, the false positive. So analysis creates 1 composite variable of a linear combination of all DVs when compared to levels of IVs and the composition variable. Eliminates the need to do multiple ANOVAs. Allows for the examination of group differences on each DV, as well as group difference on the combined construct. Creates composite variables on the centroids of all DVs. Maximizes the difference between the levels of IVs, so more likely to capture group differences not evident in ordinary ANOVA and MANCOVA. allows for control of extraneous variables believed to have effect on IVs and composite DV. Examines variations in composite DV due to extraneous variables. Reduces sampling error, which increases statistical power. The sources of variation in MANOVA. Similar to ANOVA, except that the DV is a composite variable, consists of multiple DVs. Each subject has multiple scores, one for each DV. So the within group variation consists of variations in each of the DV due to differences between the subjects with each group within the IV. Multiple tests in ANOVA. Several multivariate tests to examine group difference and their interaction on the DV. Wicks lambda, Hotelin, Pillai, and then Roy. We usually use Wicks lambda and Pillai a lot. Wicks lambda, most reported, yeah. Assumptions of homogeneity of variance. Covariance matrices and homogeneity of variance is fulfilled. MANOVA F ratio, analogous to F, univariate F ratio in ANOVA and ANOVA. Examines overall group differences on linear combination of all DVs. That is the F ratio. Signifies proportion of variance in the composite DV, not accounted by the main and the interaction effects of the IV. The Wicks lambda, proportion of variance in the composite DV that is unaccounted by the main and interaction effects of the IVs. Ranges between 1 to 0. But closer to 0, the stronger the relationship between the IVs and the DV. So it's a Wicks lambda. These ones, we don't use them. Pillai ballet, reported assumption of homogeneity. So all these things are like, notes about other things. Post hocs in MANOVA test. When significant results are dictated by the multivariate test, two problems arise. Cannot tell which DVs are responsible for the group differences. Cannot tell which pair of groups are significantly different in the composite variable. Need to do series of comparison tests to examine the following: which DV are responsible for the significant result and which DV are significantly different on which groups. Use SPSS to compute it. So other post hoc tests, ANOVA, as with ANOVA and COVA, the Benferroni, post hoc tests to understand. These post hoc are very good in understanding, which groups, where the DV responsible for the differences, so understand which differences and where it lies. The post hoc tests are always good. So assumptions, the sample is representative, and this is the kind of things you have to look at for before you are using a MANOVA or MANCOVA. So look at if the sample is representative, is it sensitive to sample size and outliers. Outliers is almost like every other place. Sample size is very, very important. Normal distribution is almost every other place, apart from PLSM. Variances on all the DVs must be equal variances. So equality of variance, equality, normal distribution, representative sample. Use the Levene's test of equality of variances. P is greater than 0.001, indicate variances of all DV across all groups are equal. Relationship between all pairs of DV is linear. So this linearity, relationship between the pairs of all the dependent variables have to be linear, normal distribution, equality of variances, sample is representative, sensitive to sample size and outliers. These are like the assumptions. And you have to know if you are the research you want to design, whether these assumptions can be fulfilled based on the kind of data you have. If you cannot be able to meet up with these assumptions, then you may not be doing MANOVA or MANCOVA. So more assumptions. The covariance of all the DVs on all levels of the IV are equal, you see. So the covariance must be equal. Problem when cells have unequal number of, look at Boss tests and all this, Multicollinearity, look for Bartlett test of sphericity. The tolerance, how to take the multicollinearity in the independent variables. And remember that the covariates must not correlate with the independent variables. So assumptions from MANCOVA only. Reliability of all covariates. All covariates should have no measurement errors. Relationship between the composite DV and the covariates should be the same for each level of IV. Yeah, Each level of IV on the DV are always, equal, They have to be the same level of IV. The relationship between the composite DV and have to be the same level. So if P is less than 0.05, McOver is not correct test. Consider ANOVA. So have to look P have to be greater than 0.05 on interaction effect between IVs and coverage on the DV. So all these things are like complex things you need to, but basically assumptions will help you a lot to figure out if this should be the appropriate test you should be using for your test. Usually it's hard. I can't remember any of the research works we have read in class that uses McOver and ANOVA. You can see a bit of ANOVA. Even the P and the U-Tout model wasn't validated with any of these statistical methods. They use PLSM, and that's why I always love the PLSM, and I hope to use it in my dissertation. I have not mastered the software, but I hope to learn it when I start doing the research. It's easier for me because I don't need to go into experimentation, all this manipulation of variable. Assign random assignment to groups because it's very hard. It could be very difficult. And also you need money and time. Random assigning people to different, like if you maybe say you're working in a school and you want to assign students to different groups, how is it possible? Is it not going to interrupt their normal school life, their semester or whatever? So it's like something that is usually, and one, you are not part of the institution, you are not even a teacher. And sometimes it's not even allowed to use your own student for research because they could introduce some level of bias. So that's why most of these experimental designs are not so much in use. You need a lot of money to do that. And sometimes you have to pay people, to randomly assign them to a group. But you see it in the medical field, the randomized controlled trials they use in testing all these drugs. Sometimes people have to be used as guinea pigs. People have to volunteer to be used as guinea pigs, to test, a drug. So I know the government spends a lot of money on research. And this is a part of the research they do, randomizing assignments, using people to text, like some people will say that the COVID is still under experimental, process. So the more they learn that people are dying, the more they might decide to shut down. There was a time they shut down the Johnson & Johnson, vaccine because there was some kind of, it's kind of experimentation with human beings, may not be controlled, but there are sometimes so in IS, you hardly see papers using McOver, but these are accepted statistical methods that can be used. And let me tell you, in qualifying exam, you're either expecting like regression or PLSM, which is ordinary least square regression. Correlation might also come in. Of course, descriptive statistics is always there to analyze, look at the scatter plot to understand the distribution in your data set, to know if you can be able to fulfill assumptions, so you don't need assumptions to do your like if you're doing PLSM. So
for the 4 or 5 or 4, most likely I would say is the question you have to not understand strap. You have to go and drink strap and understand how to build your instrument. This is very important. Second,
strap, yeah.
And the other thing is to just know and be professional for one of those statistical model. You might use one of them, and you have to be like careful to pick 2 different statistical model, because based on the question you might get specific one of them. And
yes,
that's for 5 or 4. You don't need
and also to determine if the research, because usually in qualifying exams, they will give you a poorly designed paper and ask you to critique it. Look at the paper and then think about what you would suggest to be the most appropriate design. Have to look at their model, look at their constructs, look at their variables. Was that the variables well defined, conceptualized, well operationalized? Are the theory, are the hypothesis based on the theory they are using? Do they have a theory at all? Is the statistical method they applied is it the proper one? Understand? So what other things that you need to look at? What of the insights they derive from the data? Is it appropriate interpretation of their findings? Is it accurate? Is it based on actually the information the data? Is it based on their data analysis? So are the hypotheses testable? Very clear and testable? Is the sample significant? So all these things are the things you need to look out for, in a QE exam. So I think we have tried our best, with
You did very good job, man. You did very good.
Yes, we have done our best with
thank you very much.
With the 504. By next week, we go over to 503. And then while we are doing 503, we can still make references to 504. I love that kind of connection, When you are preparing for this qualifying exam, you don't need to narrow down your mind. You need to broaden your mind. Broaden your mind means be able to connect from 503 to 504 to design science research, understand the differences, across the different groups, across the different methodologies. It helps you to broaden your mind so that you can know when it is appropriate. So sometimes someone can see a question and say, I'm going to use qualitative, when in actual sense, the person should be doing a quantitative. So you need to understand what you are looking out for. Are you interested in factors? Are you interested in the context? What will the context difference it makes? So all this decision is what is really needed for you to pass a QE exams. If you understand these fundamentals, even without going back to this text, these slides again, the general knowledge you have about all this is enough already for you to pass this exam. You don't need to begin to look at the memorizing. Don't memorize anything. Don't memorize anything. Mankova, ANOVA. Understand when ANOVA is best for you to use. Understand when ANOVA is best for you to use. Understand when regression is best. Usually, most of the questions that we ask you in the qualifying exam will be either regression. Either regression can solve it, or partial least square regression can solve it. If you will decide to do experimentation, remember ANCOVA and ANOVA could be good for experimental purposes. Remember, ANOVA is not good for quasi-experimental, it's still controversial. So you remember most of these major important ideas.
Climate, why we didn't go through the equation structure model?
No, I forget. Next week, that's what we are going to handle. I even forgot that, so I was thinking we are finished there, whatever. So next week we are going to do the partial least square. I'm going to spend time there.
That is my weakness, and this class is equation.
Oh, no. I'm going to simplify it. I'm going to make it very simple. Yes, I'm going to make it very simple. I will bring it to the level you will understand it. Because I know partial least square very, very well. Yeah.
I promise.
Yeah, I know it very, very well. What I have not mastered yet is to use the software. Understand? Yeah.
Okay.
All right. I think we have to, at this point in time, we have done a great job. This is 10 p.m. I will leave you now to go and then grab something if you have not taken anything for dinner. And then I hope to see you next Monday. Do well to contact me anytime, any day on WhatsApp. If you have any questions about anything, I'm always available to share.
One more thing, Clement. If I need you for something in a different schedule, can I connect with you for 1 more for 1 hour or 15 minutes?
Chat me up on what? Chat me privately on WhatsApp, and then tell me what is it. We can figure out the best time to discuss it.
Okay, thank you very much.
I'm always flexible. Yes.
Okay, thank you.
Thank you so much, and do have peaceful night.
Okay, you too, man. Thank you very much.
All right. Bye-bye. Yeah.